Okay, I want to do two more examples. The second to last example of a separable equation that we want to do is let's look at, so let's solve the following. So I want to solve y prime equals y, over x times 1 minus x. Okay, again, no initial values, just we want to solve for it. And we're going to do the usual stuff at this point. Hopefully it's feeling pretty second nature. We're going to separate variables, and that's going to leave us with 1 over y dy equals 1 over x times 1 minus x dx, and integrate both sides. And when we integrate both sides, the left side is, of course, just the natural log of the absolute value of y. The right side, we need to figure out how to address this. And there's two ways. One is that you could distribute the bottom, complete the square, and do trig substitution. Don't do that. The other way is partial fractions. It turns out that partial fractions will be a much nicer way. This is going to turn out to be, let's see, we're going to have an x and 1 minus x. So let's see if we could just figure this out without having to go through the formal partial fraction decomposition process. I think this should be 1 and 1. I think that's it. Because you're going to end up with 1 times 1 minus x plus x. And that'll just give you 1. So there we go. So there's a partial fraction decomposition. This tells you that the natural log of the absolute value of y is equal to the natural log of the absolute value of x plus the natural log of the absolute value of 1 minus x times a minus 1. Okay, and here we use the fact that if we integrate a plus bx, this is going to be equal to the natural log of the absolute value of a plus bx divided by b. Of course, plus c. Okay, but whatever, ignoring the plus a constant here. Okay, so that's the thing that we did there. So we had we divided by. So here we divided by minus 1. That's where that minus came from. It's really a 1 over negative 1 there. And then, of course, plus our constant c. And then finally, when we solve for y, at least we solve for y as much as we can. We could solve for y if we want to. Well, let's see how far we can get. Sometimes it's not possible to always solve explicitly for y. We just have to leave it in a certain form. In this case, I think we can solve for y pretty much. So let's exponentiate both sides. So we're going to end up with e to the natural log of the absolute value of y is going to be equal to e to the natural log of the absolute value of x over the absolute value of 1 minus x times e to the c. And again, if you like, that means that you can actually just write y is e to the c, or just another constant, times the absolute value of x over 1 minus x. Okay, and there's our solution for the differential equation. Okay, so that turns out to be, those are the functions satisfying the differential equation that we started with.